Hey, Jinchi.
Hi, Anu. Yeah, I'm here.
All right. Let's just wait for a couple more minutes, Jinchi, to see if we have more people joining in, and then we can get started.
Okay.
Why don't we get started, Jinchi, then?
Okay, Anu. Yeah, hi everyone. Thank you for joining the Clam office hour. My name is Junqi Wang. I'm the Clam developer. And in this demo, I'm planning to show a basic introduction of this Clam software. And then I can talk about more about the comprehensive clinical pipeline in Clam, which is the NER attribute pipeline. And you can stop me anytime if you have a question or you want to discuss more about the detail. Or you can type a question in the chat box too. I can see the chat box. So let me get started. Yeah, share my screen. So the Clam software, it's available as a zip package. You can just download and then double click to run. This is the welcome page. In this page, you can go to the Clam document, tutorial videos, and FAQs. And say go to the workbench. And this part is a primary interface. We have several views. So in the left part, we have the component view. which contains all the building blocks of the machine learning component or the natural language processing component. For example, in the NLP component, we have the post tagger, we have the concept recognition, and in any of all of these components, we have different processors. So processors like the specific algorithm to finish the component task. For example, in name-entity recognition, we have a CRF-based, which is machine learning-based approach, or diction lookup, or regular expressions. The regular expression is useful when you try to match some like lab values, these number patterns. And then the left corner, we have the corpus view, which is like the language resources. In the corpus annotation, you can define your own semantic types and do the manual annotation, and then build the machine learning model here. And in the pipeline view, that's a place where we can drag and drop all these NLP components and build a specific pipeline. So I can use the pipeline as an example. So if you want to build pipeline, go to new project and then type a name. I'll type something. AI attribute. And there are two tabs. For corpus annotation, select this one. And then the NLP pipeline, select the next one. Say finish. And then you may see a new pipeline project. That's the folder structure. It has components, it has data. Data is for the I/O input and output. And the components, we have the pipeline file. It's empty now. And then what we can do is, based on the project requirement, you can drag and drop from the NLP component to this pipeline. For example, if we want the concept recognition, name-entity recognition, we can drag and drop the machine learning based one to this pipeline, right? And you may notice there are error message here. Say if you want to run this pipeline, this component, then you have to drag and drop more, right? It says require post tagger, sentence detection, section, tokenizer. That's an error message. You can keep drag and dropping based on this error message, or I have this auto fix button here. Hit on this auto fix, it will try to drag and drop all the missing components automatically into this pipeline. So now we have a very simple pipeline, right? It starts from a sentence detector, which is break the nodes into sentences, and then tokenizer, break the sentence into tokens, and then post tagger. This one is to recognize post tagging of a word. Basically, say this word is a noun, this word is a verb, this word is an adjective, things like that. And then section header identification. The section header is used to break the whole notes into different sections, like the presence of illnesses, or family history, or discharge medication, all the sections. So the last one is the name-entity recognition. For each of these components, it's customizable. For example, if you double-click on the diction-based section, then you may enter the configuration page. Say the sentence section identifier, it has a parameter here, which is a file called section map. And if you go to the left side, the section map, double click on it, you can review the content of this section map. Basically, it has two columns, right? The first column is the potential section header in the notes. And the second column is the normalized name of this section header. For example, if you see source and the reliability, then that probably is a section header. And if it's a section header, then it's normalized to this value. And similarly for plan recommendation, normalized to plan section. So one good thing about this customization is that sometimes the default settings here is not enough for your own nodes. You may have your own nodes and there are maybe other patterns of the section header. Then what you can do is just add the new potential section headers into this file. Expand this file based on your own data set. And then save everything. That's how to customize the section header. And similarly, for the machine learning based one, if you double click, you see it's take a model file as input. So this model file is provided by CLAMP. It's trained based on clinical notes from CLAMP. It has about 3,000. These are summaries and the general medicines and other clinical notes. So in these notes, all the semantic types like problems, treatment, and the test names are highlighted. So then we train this model, release it as a default model jar. And if you want to build your own machine learning model, that's the place where you go to the corpus annotation, do your own annotation, and then train the machine learning model. We can talk about this part later. So that's a basic pipeline, and then let me prepare the I/O part. So that's the component part, right? Next is the data part. So for the input and output, we can connect to database. And here just fill in the driver jar file and the driver class. The CLAMP is developed using Java, so we need the jar file and the driver class to connect to the database, the JDBC driver, and the connection URL for the database and username, password. And next part is about the data, your input table name, and what is the document ID field, what is the text field. And then for the output, we will output all the entities into one table, all the relationships into another table. So for database, you configure this page and then say run pipeline. And for the normal file IOs, we have an input folder. You can copy some data from system. CLAMP will take the text file as input. Copy it to the input folder. And if you double click, you see that's one of the empty sample nodes, which is like a simulated clinical nodes, not a real one, but it's public available. We can use that as an example. So that's a discharge summary, contains several these sections, and then contains medication. We want to extract all the clinical meaningful information from the notes. For example, all the name of the medication and the procedure names and the diagnosis information, right? So let me try the default one on the input file. Let me select this pipeline and then run it. So if you select pipeline, go to the run pipeline icon. Then in here, it has some information output. So first, the CLAMP will try to load all the NLP resource into memory and then start to process the file one by one. Then we have progress bar here. Maybe during the pipeline running, you want to cancel it, then go to the progress, and then maybe I can show later. So there's stop icon. And in the output, so for each input file, we have two output format. One is the text format. Basically, it's a tab delimited format. Has several columns. First and second column is the start and end character offset of the concept. And then we have a semantic type, which means type of the concept is that a problem, is that a treatment, is that a test. And we have additional columns, one here called QE. So if you're familiar with the UMLS, Unified Medical Language System, the QE is just the UMLS concept ID. So basically, CLAMP can map the entity from the nodes to a standard concept in the UMLS. And then next column is the assertion information. Basically, this column will tell you if the concept is negated or not. So sometimes you see a problem in the notes, but it actually the patient denied something. That something is problem, but it's negated. That negation information is in this column, and the end column is the entity itself. So the type-ln format is designed if you want to import the output into database or write some maybe Python script to get statistics or downstream tasks like predict modeling. So you can use the text output. And also we have the XMI output, which can be visualized in the CLAMP software. So in the XML file, double-click to open it. All these information recognized are highlighted. And on the right side, we have a display option here. Basically, you can change the color, or you can say don't show the concept, or just show one type of concept if you just focus on the clinical problems, or select them all. And in the display option, the other things we can do is show the basic analysis on the syntax. So basically show the section result. Say from here to here, that's one section. And then from here to the next one, the end, that's another section. And may also see the sentence recognition result. So from here to here, that's one sentence. And also show the result of tokenization. I sometimes use this option for debugging purpose. Basically, that's useful when you try to write some rules or trace in the dive into the detail of the machine learning feature things. So for any of the concept, if you highlight this concept, you may see the attribute. So this pipeline we just run, that's a simple pipeline. It doesn't have any more attribute here. We can try to drag and drop more and show the difference. So that's our pipeline. And now let me drag and drop. Let's go with the assertion classifier. So we can drag and drop from the NLP components to this pipeline. Now we have a negation after concept recognition, right? If you double click on this negation, it's also a configuration file here. Double click, open it. You see that's a collection of all the possible mentions of the negation phrase. It has negation phrase, it has a post negation phrase. So again, if you see the default configuration doesn't work very well, for example, it missed some negation mentions, then you can go to this negation dictionary and try to add more entries from your own data set. So yeah, this file has several tabs of the several item types. It has negation phrase, which means negation, and has a pseudo negation phrase. It means it has a not or no something. It looks like negation, but actually the meaning is not negated. And I think I also have some post negation phrase. So that's a negation phrase after the primary concept. say something might be ruled out for. Yeah, so you can customize this file based on your own data set if you want to, improve the performance of negation recognition. So let me run it. So here in the GUI, every time you click Run Pipeline, it will load the resource again. So, but if you want to, integrate the pipeline into your own system, actually you don't have to load the resource again and again, right? Only during the initialization, load one time of the NLP resources and then process all the data set. I think it's finished. If we go back to the output, then you see now we have an additional output from the negation component. It says this concept now is present. I think there are some, I don't know if there are negation example in here. Oh, no significant. Yeah, anyway, that's the idea. So I didn't find a negation case here, but if concept is negated, then in the addition part, we may see an absent here. So similarly, we can drag and drop one more from the concept mapping to the dictionary. I think, yeah, okay, it's running. So what I just did is drag and drop from the dictionary-based UMLS encoder to the pipeline. This encoder means for each of the concept, we will try to get the standard concept ID, the UMLS QE for the concept. So it takes a while to drag and drop because when you drag and drop the UMLS concept, the UMLS encoder, the client will need to make sure you have the UMLS username and password. Basically, make sure you have the access to the UMLS content. So to use the UMLS encoder here, you have to create your own UMLS account, username and password. So the first time you drag and drop, client will give you a dialog like this, the UMLS username, password, and we will validate it to the UMLS website, make sure the username password is correct. So only when this one is correct, then you can use the dictionary-based, the UMLS encoder here. So once we have the UMLS encoder, if you run it again, it's not finished yet. Yeah. So now you can see more attribute in the attribute dialog, the QE concept ID, and this QE description means the official term of that concept. So in this case, the concept ID, the UMLS encoder, this component is also customizable. Every component is customizable here. So the concept mapping component has more options. Basically, we have a mapping here. Say if a concept is recognized as a problem, then we may use, we may also need the SNOMED city concept ID. If the concept is recognized as a drug medication, then we need the ARC-SNORM concept ID. So you can add more mappings here. Say if it's recognized as a treatment, then we don't have a treatment. And then if it's a lab test, then we may use the LONC ID here. The default source supported by the current version is SNOMED CT, LONC, ICD-10, and RSNOM. In our future release, I may expand the list here to support more specific terminologies. So yeah, that's how to add one more entries here. And also you can say edit or delete. With this setting, then if you look back to the attribute, we see there's a Umlas QE here and also a SNOMED CT concept code, because the semantic type is a problem, right? And similarly for all the concept. Treatment, only Umlas QEs. And for test, it's still QEs because we changed the customization, but we didn't rerun the pipeline. So it doesn't give me any LONC code. Okay. So far, I demonstrate how to build pipeline from scratch. It's like a data-driven approach to customize and drag and drop pipeline developments. So far, any questions, discussions?
I have a question about the data input. So when you use a database, so what is going to happen behind the scene? Are you going to read from database and then write it in a file and then read it from file, or is directly everything is going to be from the database to your code?
Yeah, from database to database. So okay. Database part is just configure the JDBC driver, read from database. So in the database, your input table should have a field to serve as a document name, and then another text field for the NLP to process. And the output is read in 2 additional tables. What CLAMP will do is to create these 2 tables in your database and save all the output into these 2 tables. Does it make sense?
Yes, but I'm still interested in to know what is going to be the whole process behind the scene. So when you read it from a table, okay, from database, are you writing it in a text file and then your code is going to read it from a text file or not?
No.
Okay.
Yeah. So the content is all in the memory. We will create a document in the memory and then process that and save the output, right? We don't save the content to a temporary file just for input. Not like that. Okay.
Awesome. Thanks.
Yeah. Yeah. So yeah. Okay, I showed several of these basic components, and actually sometimes in the clinical tasks, the concept recognition itself is not enough. We need some kind of like a relation extraction, right? So that's why in our pipelines, we have several advanced components. Maybe I just show it in the AR attribute pipeline. So you can see this pipeline, it contains maybe 20 of the NLP components, from sentence detection to dictionary to the concept mapping, and also it has several more components like the problem attribute recognizer, the modifier recognizer. The modifier means for a specific problem, it has some modifiers. Modifiers like the body location of this problem, the severity of this problem, or the subject of this problem. So subject means maybe the patient's family members has some problem. The problem doesn't belong to the patient, right? And modifier also include like a condition modifier. Condition means something like contact the doctor if the patient have a fever. The fever is problem, but actually that's a if, right? The if is recognized as a condition. So that all these modifier will be covered by the problem modifier recognizer. And for other types like medication, we have 3 components here. And these 3 components are trying to recognize all the signature information for medication. For example, the dosage, the frequency, and the duration of that medication. And then for the lab test, this component here, test value recognizer, is trying to recognize the value and connect the value to the specific test set. And also we have an optimized encoder just for the medications. We'll give the RSNORM concept ID. So this pipeline, CLAMP NER attribute pipeline, is like the most comprehensive pipeline in CLAMP system. You can find this pipeline in pipeline library. So the pipeline library is like a collection of all the pre-built, the existing pipeline in CLAMP system. These are some of these very common clinical NLP tasks, like the concept recognition, and also has a de-identification pipeline here. Basically, remove all the PHI information and the colorectal cancer bleeding, that's for specific disease. And this pipeline library, actually, that's collection of existing NLP work. That means if you use CLAMP to develop something, then you can export your pipeline as a library, and then save the pipeline into here. Yeah. So I include an example here that's a pipeline from PC Technology, our customer. So you can create your own collection of the pipeline and then reuse all the NLP works. So for things in the pipeline library, it's like a zip package. It's read only. If you want to run the pipeline, drag and drop from pipeline library to my pipeline. I already have an existing one here, so I have to rename it to maybe add a number. So now it's like unzip the resource in this pipeline. It's finished. Now you may see the pipeline from the library. So usually what you can do is after you have your own data set, try this NER pipeline. That's for the concept recognition. And then try the NER attribute pipeline. That's the most comprehensive one with all the signatures and modifiers. So if you run this pipeline, it may take maybe 1 minute to finish this pipeline. So I pre-run the pipeline on some of the NLP nodes. Let me show one here. That's the output of the NER attribute pipeline. You can see more information compared to the basic pipeline we just created. So for problem, it recognizes the body location and the tempo connection. And yeah, here's another example for the problems. It tried to recognize the severity information, mild to moderate, as shown example here. And also another example, course. Course means if problem is increase, decrease, basically the status will change of a problem. If it's relieved or get worse, something like that. And for the lab test, the vitals here, recognize as the test and then connect its associated values. And for medication, recognize the frequency and duration as a signature, connect to this medication drug. And some more example here, that's a negation modifier. Yeah. And again, for some attribute, it's available in the attribute dialog. The negation, concept ID, and I think for the medication, we have the RSNORM concept ID and the generic concept ID for this medication. So basically, all the information highlighted in the CLAMP interface, all these information are actually in this XML file. And the XML basically is just like a XML. It's a structured data format. If you're familiar with UEMA, then it's very easy to understand. I can show this structure a little bit. So, oh, I already have it here. So if you open this one with the web browser, where's my Google Chrome? Then that's the format of this XML file. You can see the sentence information from and then token information from here to here. That's a token, and part of speech is a none. And then trunks means like a phrase, a combination of several words, like a noun phrase, a verb phrase, and then, yeah. The concept recognition. So there are some more information in the XML file, which I didn't show in the CLAMP GUI, but it has some scores, like a confidence score of the concept. It has a sentence probability, has a concept probability, and then all the other attributes, like QEs, assertion information. And let me explain the score a little bit. So when we run the machine learning algorithm, for each of the machine learning output, it will give us a score. The score is like a probability of that concept, right? Sometimes you can use the score to filtering all the output concept. For example, if you want a high precision or something, you want the output as accurate as possible, you don't mind missing something, then you can set a threshold here. Say only keep concept score which is higher than maybe 0.95. The difference between sentence probability, concept probability, the sentence probability means the whole combination of the concept in one sentence. It's like global confidence on the sentence level. And the concept probability is the confidence score on the individual concept. So if you want to filtering based on sentences, then you can use the sentence concept score. Or if you just want to filter based on the concept, then use the concept probability here. Or maybe you try to multiply these two to get a final score. It's all possible. I think it's depend with how to filter and concept. It really depend on your project requirement and your data set. Right. So let me see if I have more. Relation. Yeah. Here's the relation information. Basically, it has a entity ID, say from which entity to which entity. It has a semantic tag. And the entity, you can find the entity based on the entity concept ID. So 1113, that's a concept here. It's a temporal. Yeah. So that's how to get information from XML file, pass it as a XML, extract the structure information. That's one way. And the other way, I can see. The other way is that the client provide the programming API to pass all the NLP output. I have some demo code. For example, if you use the CLAMP NLP as a library, then you can new a document object and then throw this XML file as input parameter. And after that, from this document object, you can see get file name, get sections, get sentence, get everything. And then for each of the concept, you can get all the attribute. That's an easier way to extract information after NLP. Okay. So that's about the NER attribute pipeline and the output. Any question, discussion on this part? Or we can switch to the machine learning model building part. Okay. So the next feature I want to talk about is the corpus annotation and the model development. You see all the pipeline file I just showed. If you look at the name entry recognition component, the model file, all the machine learning model file, we are still using the default one from CLAMP. But sometimes in your application, you may want to build your own machine learning model. For example, the default one recognizes a problem treatment test, but in your new project, you may extract something different. For example, maybe a gene name or a protein name or yeah, things like that. So in that way, you cannot simply use what we have as a default model here. And in that case, you have to go to the corpus annotation part to annotate your own corpus and then build a machine learning model. And in CLAMP, we can do that. So create another different type of project. We call it, oh, I have too many demos. Okay. So you can create a new project, and now it has a different folder structure than compared to the pipelines. Right now, we don't have a component, but we have a corpus folder. It contains a train folder and a test folder. That's a place where you can place your training data, and this is a place you can have your test data set. And also has models, which is empty now because we haven't developed anything yet. And most importantly, we have a depth-defined XML. If you double click open, and that's a place where you can define what kind of entity you want to annotate, what kind of concept you want to annotate. And we can define something. So right click on this entity and then give a name, anything you want to annotate, and maybe, yeah. So add all the concept name you want to annotate here. And what's cool is you can define like a hierarchy structure in the entities. For example, in the problem, maybe there's a subtype, we can call it diagnosis. Then this entity is really could be a tree structure. And in addition to the entities, we can define relationships too. Also right-click on the relation and then define something, location of. So the relation is, we need an interface dialog here to define the relation, because for a relationship, we want to define from which kind of entity could this relation be. So we define location of relation, then we say the relation could be from body location entity to problem or to diagnosis. Save. Then now you can see a relation definition. Name is location of, from body location to problem and diagnosis. So let me close it. After we define the types, next step still will be copy some notes and then paste it to this CLAMP folder. I copy something to this training folder. It's text file, but if you double click, CLAMP will run some pre-processing, convert to its own format, XML, and based on which you can do the annotation. So yeah, I just randomly select something. If you select the text and then assign a semantic type, that's how to do the annotation. And maybe select something as a body location. And for relationships, you can drag and drop from the body location to the problem. That's how to annotate the relations. So you can keep annotating until maybe you have hundreds of the nodes and then start to build a machine learning model. So once you have enough training data here, next step, you can select the training folder and then go to the training icon here. And this is the dialog about how to train the machine learning model. You can assign a model name, the location of the training corpus, and here is all the feature engineering part. In CLAMP, for an inventory recognition, current release, we are still using the CRF, the conditional random field. So in CRF algorithm, we need these feature engineerings. So you can select them all. Generally, it works good on clinical nodes, but you can also try different combinations of the features if if you're familiar with these feature things. Sometimes maybe a subset of the feature, it can have an even better performance on your data set. Carefully design the feature engineering may improve the performance, but yeah, you can start with select them all. And then we have our evaluation. So after model training, we can decide if we want to use an individual test set to evaluate performance or use a cross-validation. Basically, split the training data into several parts and then use one part as a test data and all the remainings as training data, and then repeat that several times. That's for cross-validation. You can select them all or just use one. Cross-validation for most of the times. And then after configuring this part, hit this finish, then it will start to train the machine learning model. I will not click finish because I only have one document and only annotate two concepts. But in the Clam release package, I have a demo corpus. Let me see which one. I have too many demos. Yeah. So the demo corpus here, it's come with the Clam release package. In this corpus, I have several hundreds of the clinical notes, the training corpus from Clam. All the problem treatment tests are annotated. So if you want to play with the machine learning model training part, you can start with the demo corpus project, come with the default package, select the training folder, and then go to the train icon here. So for demo purpose, I will just use one feature to make it run faster. Of course, if you can imagine, if you select more, the model performance may be high, but the training speed, the training time is longer too. Similarly, if you have more training data, the training time it will be longer too. So try with cross-validation and then hit finish. Then we also have a progress bar. That has individual tasks for each fold. We have I run a file fold, so it's 0 to 4. And in the console, you can see all the output. All the iteration information is from the conditional random field algorithm. Oh, already have something, so I can. Let me try to cancel it. I just cancel the cross-validation because I already have something right here. We don't have to train. So for the output, you can find a folder, a subfolder for all the machine learning models, and that contains several things. One is the model file itself. This is the machine learning model itself. You can copy this one and then go to the machine learning, go to your NLP pipeline, place it to the CRF name recognizer, and then change the configuration. Double click, and now it's default model. We can switch it to the new model file which is generated, and then save everything. Now you are running our own machine learning model, not the default one anymore. That's the model jar file, and also we have the training feature. So if you're familiar with the CRF, the sequential labeling algorithm, you can easily understand the format. The first column is the BIO tag, and all the remaining is just the feature, but in string format. And then the log file, it has every detail information of the training process. And if you go to the end of this file, I may give you some performance report. You see, in this case, I only use one feature and they reach a performance of 70 something. If you select all the features in the training, then probably this score should be higher 80 something. And in the output, it contains all the XML files from the training, but in this XML, I will show the original annotation with the machine prediction. So you see for this problem, it's annotated as a problem, also predicted by the machine as a problem. So this is a true positive. The machine did a good job. And then there are some other cases like here. It's not annotated as a, what's that, probe treatment, but it's recognized by the machine as a treatment. So this one is a false positive. And there are maybe several reasons for this. One could be the machine make a mistake. In that case, maybe you can go to the feature engineering part, try to improve the machine learning performance. And also it's possible that the human annotation actually misses this part. So the machine is correct, but the annotation is not correct. In that case, you can go back to the training corpus, add the missing piece. So then you can imagine the whole workflow. It's an iteration of feature engineering and refine the annotation until you get a reasonable performance on the corpus, and then use the model in the NLP pipeline. Okay. So after finish a machine learning model, the NLP pipeline, the next thing should be you can right-click on the pipeline, then say this pipeline is ready. I can export the pipeline as a jar file, and then with this jar file, I can run it on the Linux server or on other place, not in this GUI, for big data processing. We can use a multi-thread or multi-process to process a large data set. Basically, the GUI here is like a development environment. And after everything is developed, release this one as a jar file, and then run with a command line version and process the big data set. So yeah, I think that's pretty much what I want to demo today. And any questions about the machine learning model, corpus annotation, and other related questions?
If there are no questions for Junchi, then I think we can finish a couple of minutes early. Thank you all for calling in, and thanks Junchi for doing the demo.
Yeah, thank you everyone. If you have questions, give me an email. You can find my email on the CLAMP website, the technical support.
Bye.
Okay, thank you, bye.